Hello, everybody. Welcome to day 10 of Math 1314. Today, we're going to talk about Chapter 4, Polynomials. In the first section, let's talk about what polynomials are. Poly means many. A nomial is a number or we're going to call terms. So a polynomial is an equation made up of many terms. Remember, a term is anything separated by a plus, minus, or equals. For example, monomial. Mono means one, so it means one term. That could just be a letter, a number, a letter, a number, or number, a bunch of letters. It's just one term. There's no plus or minus or anything in there. Binomial. Bi means two. Two terms. It's like 3x plus 2, 7x minus 5y to the third. Everybody saying it has one plus or minus in there. A trinomial, tri means three. So it's like a quadratic equation. So you have three terms, but that means you only have two pluses or minuses. A quadrinomial, quad means four terms. Like 3x to the third minus 4x squared plus 5x minus 3. There are four terms. That means only three pluses or minuses. Anything higher than that, usually we simply say it's a polynomial of degree n. Where n is the highest exponent. Right? Now, another thing, when you talk about polynomials, solutions are the same thing as x-intercepts or factors. So whenever you hear solutions, it all means the same thing. So when we solve these things, when we solve polynomials, we have to make sure that we set them equal to 0. So here we have a binomial. There's no exponent, so it's a linear equation. The way you'd solve this is set it equal to 0 and solve for x. Subtract 2 from both sides and divide by 3. So the answer is negative 2/3. That's the x-intercept. Remember, x-intercept, you find the x-intercept by first set the y value equals 0 and solve for x. We did that in chapter 1. All right. That's good. If we had a quadratic equation with 3 terms, you have to set that equal to 0 before you do anything. It has to be set equal to 0, and then from there we can try to factor it. X squared is x times x. The second sign being plus means they're both the same. They're both the first sign, they're both pluses. What times what is 6? When you add them, you get 5, 3, and 2. So once you took a polynomial, factored it out, now from the 0 product principle, which says anything to multiply together if it equals 0, that means one or both of the equation numbers are 0. So if we have a times b equals 0, that means either a or b or both equals 0. So what that means, we have to take both of these equations, set them equal to 0. So x is negative 3 and x is negative 2. These are our solutions. They're also our x-intercepts, because at that point, y is equal to 0, and that's what x equals. All right, if I give you anything higher than quadratics, right now, you couldn't solve that unless I gave you the factors. And that's what this chapter is all about. We're going to learn how to take these equations and solve for their factors. But right now, if I gave you the factors, you set that equal to 0, we can find the x-intercepts and find the solutions. So x plus 4 equals 0, x plus 1 equals 0, x minus 3 equals 0. So x equals negative 4, x equals negative 1, and x equals 3. From chapter 1, we learned whenever you have something in parentheses, it's always the opposite sign of what's the answer. And the answer is opposite sign, what's side there. All right, so that's eventually what we're going to get to in this chapter. Okay, what distinguishes a polynomial from a non-polynomial, the graphic wise? Polynomial versus non-polynomials. Polynomials are continuous. There's no break, no anything. Non-polynomials have points. They're non-continuous. They're continuous, they're smooth, which means no pointed spots. Okay, what is that? What that means is like a linear equation, a quadratic equation, a cubic equation, cube root, and any higher polynomials. So non-polynomials are equations like the absolute value, equations that have a jump, equations that have a break, equations that do not go from negative infinity to positive infinity. Like the square root of x, it begins at 0 and goes on. Or 1 over x, or 1 over x squared. Those equations. So that's the difference, because if it has a point, that's a non-polynomial. Polynomials, you have to be able to put your pen at one point and be able to go anywhere, both directions, without ever stopping or picking it up. All right. Let's look at what's called the leading term. The leading term is the first term of a polynomial it has the largest exponent. So whatever n is, that's the highest. The next one goes down all the way down to a constant. So the leading term, this is a polynomial. The leading term is that first one. What does a leading term do? It dictates the shape and direction of the graph of the polynomial. It has two parts. It has the leading coefficient. That's whatever's in front of the x. And it has the degree. the x part of the polynomial, of the leading term, is an exponent. And the bottom of the x part is called the base. Now, how can this help us, the leading term help us? Well, let's look at this. So we have the coefficients on the top and the degree on the column. So if the coefficient is positive or negative, the degree, the n value, is either going to be even or it's going to be odd. If the exponent is even, that's that power of n, and the number in front is positive, then we know that the graph will look something like this. Both ends will point the same direction, they'll point up. If the leading coefficient, the degree, is even and the leading coefficient is odd, then the graph, both ends will point the same direction, but it'll point down. So if it's even, same directions, either up or down. If it's odd, then they go opposite directions. If the exponent, the degree, is odd and the coefficient is positive, then the left side goes down and the right side goes up. It's an increasing function. This is the definition of increasing function, because if we start our pencil here, keep on going, the graph is always going up. If the coefficient's negative and the degree is odd, then it's a decreasing function. The left side goes up, right side goes down. And that's by definition what a decreasing function is. Let's look at some examples. X equals x squared minus 2x minus 8. Remember, a polynomial has this form: ax squared plus bx plus c. In this case, is a is 1. So a is positive, and the degree is even. So we know the graph of this equation, since it's positive and even, the graph will look something like this. And the degree tells us we're going to have at most 2 solutions. Again, the degree tells us the maximum number of x-intercepts or solutions. So we set it equal to 0 and factor it. The first term is made up of x times x. The second sign's a negative, so that means the signs are opposites. And the bigger number is negative. What times what is 8 when you subtract them, you get 2? 4 times 2. So the 4 goes in the negative. 4 times 2 is 8. 4 minus 2 is 2. We set them both equal to 0. And we get our solutions, our x-intercepts. Let's look at another one. Our leading term, a, is 1. That means a is positive. The degree, n, is 2. So that tells us both ends point the same direction. They both point up. We know from this equation, we know the y-intercept is always the constant. So let's go ahead and solve this. We set it equal to 0. And we find the x-intercepts. Well, we can do it 2 ways. We can add 4 to both sides. So x squared equals 4. To get rid of the square, we square root both sides. So whenever you square root something squared, you have to put a plus or minus in front of the answer. Square root of 4 is 2. So the answer is x equals positive 2, x equals negative 2. These are my x-intercepts. Or I could factor it out. 4 is the same thing as 2 squared. And we know the difference of 2 squareds is a plus b, a minus b. So if it's a minus sign between 2 squared terms, then we just take the first plus the second, the first minus the second. That's the difference of 2 squares. That's a formula. Set them both equal to 0. And we get our solutions. Okay, we have x cubed plus 2x squared minus 5x minus 6. What do we know so far? We know our leading coefficient, a, is 1. A is positive. N is 3. It's odd. So since n is odd, a is positive, the graph will look something like this. We know the y-intercept is the constant. We know the degree, we know the shape and direction. So if I gave you the factors, then set that equal to 0, then we could set each of these equal to 0, and we could find our x-intercepts. X equals -3, -1, 2. So the graph of our equation here's one at -3. There's one at -1. All right, so because of the shapes like this, that means from the last point, we know it goes down. And from the farthest right point, it goes up. So the graph will look something like this. And we have a y-intercept at -6. So we know all that stuff. So if I give you a bunch of information, you could eventually find out what the graph looks like. Yeah, but for right now, I'm going to give you the factors, and that's what the goal of this chapter is, so we could find our own solutions. -x⁴ minus 5x⁻³ 2x² plus 12x plus 8. We know that a is equal to -1. We know that n is equal to 4. So the a is less than 0. And n is 4, it's even. So we know the graph will go down. Both ends go the same direction. They both go down. That's what the graph is going to look like. We know the y-intercept will be at y equals 8. Yeah, the y-intercept is always the constant. So right now I'll give you the factors. Since we have two of the same type here, there's two of those, and there's two of those. Now, we know that these are our intercepts. So our intercepts are at 1 and -2. But now, these numbers up here are called the multiplicity. Multiplicities tell us if the graph crosses or bounces off the x-axis at that 0. So if the multiplicity is even, the graph bounces off the x-axis at that point. if the multiplicity is odd, the graph crosses the x-axis at that point. So if the multiplicity is even, it bounces. If the multiplicity is odd, it crosses. So we see here our solutions are at 1 and -2, and they're both positive. They're both, not positive, they're both even. So at both of these, the line's going to bounce off it. Since we know the degree is 4, that means the lines go in the same, ends go in the same direction, and it's negative. They both go down. So what happens is the graph bounces off that, then it goes up here and bounces again, and it goes on forever. And that's the shape of a fourth order equation. Let's take another example. F of x equals 5 times x minus 2, x minus 2, x minus 2, x plus 1. So this becomes 5 times x minus 2, since it happens 3 times, cubed, and then x plus 1. It only happens 1 time. The degree, if we add the exponents, that's the degree, the exponents of these solutions. So we know that's degree 4. We know that a is going to be positive. How do we know a is going to be positive? Because that's positive, that's positive, all the x's are positive. So when you multiply all these together, you get the leading term. X times x times x times x is x to the 4th times 5. So it's positive and degree 4, so we know our graph is going to point up in the same direction. This says they both end up going the same direction, and this says they're both going up. So our x-intercepts are 2 and -1. So those are x-intercepts. I know that both ends, they go up. So it has to, it's an odd exponent, so it crosses at -1, it crosses. It bends, it goes back up. And it crosses at 2. This is an odd exponent. So the graph looks something like that. So again, that's what the exponents and numbers, that's what it all tells us. So without doing any math, really, we could have an idea what it looks like. Let's try this method, factor by grouping. So if we had x cubed minus 2x squared minus 9x plus 18. If you have 4 terms, then try this. The way you do grouping is take the first 2 terms and put them in parentheses. If there's a middle sign's negative, put it inside the second parenthesis. So you put parentheses on the first and second half. Put parentheses around first 2 and second 2 terms. Factor each parenthesis. So what in the first parenthesis, what does it have in common? What do they have in common? They both have x squared. They both have 2 x's. So since I factor out the x squared to see what goes inside there, I divide by x squared, both terms. X cubed divided by x squared, so it means I subtract 2, so I just have x minus x squared, so I just have 2. If second term starts with a negative, factor that out. So if the second term starts with a negative, factor out the negative. So they both have a negative and they both have a 9. So I divide both of these by negative 9 to see what was in the parentheses. The negatives cancel. 9 divided by 9 is 1, so just x. Positive divided by negative is negative. 18 divided by 9 is 2. Now we have only 2 terms. Factor again. What do these 2 terms have in common? They both have an x minus 2. Factor out common terms. Place the coefficients inside their own parenthesis. So this and this goes inside their own parenthesis. So now, once you do that, factor again. Okay, do these 2 have anything in common? No. Can this one go any further? No, it's linear. How about this one? It's the same thing as x squared minus 3 squared. It's the difference of 2 squares. Remember, difference of 2 squares? X plus 3, x minus 3. Set that equal to 0. Set them all equal to 0. And we get 2, negative 3, and 3. We know we're supposed to get 3 answers because degree equals 3. So at most 3 solutions. So we have it at -3. At +3 and at +2. We notice that their multiplicities of the factored forms, they're all 1. So they're odd. That means the graph will cross through there. A is 1, which is positive. N is 3. It's odd. So that means it's an increasing function, opposite side, opposite directions. And we know that it crosses through the y-intercept at 18. So there's our graph. Let's look at another one. I'll just make one up. P of x equals x plus 2, x minus 3, x minus 3, x plus 2, x minus 3, x plus 3, x minus 3. Let's see. Okay, how many x plus 2s do we have? There's one there. We have 2 of them. How many x minus 3s do we have? 1, 2, 3, 4. How many x plus 3s? Just 1. So if we add the exponents, we have 2 plus 4 plus 1 is 7. 1, 2, 3, 4, 5, 6, 7. So that's my degree. A is positive because all of the x's are positive and there's no negative coefficient. So we know that our graph, since it's odd degree positive, both ends point different directions. The solutions are at -2, 3, and -3. So we have at -3, -2, and 3. We know the opposite directions. So at -3, it's odd, so it crosses. At -2, it's even, so it bounces. And at 3, it's even, so it bounces. The multiplicity is even. If it's even, it bounces. If it's odd, it crosses. So that's what the graph's going to look like, about, approximately. All right, so that's section 1. Section 2. So we learned how to graph. I mean, we have the x-intercepts. We see if it bounces, which direction, by the degrees. There's another important value here. It's called the intermediate value theorem. This theorem tells us if there's an x-intercept between two different x values. This is what pretty much this is what it's saying. We have a curve. Let's say this is A. That means this point here is f of A. And let's say this point here is at B, and that's f of B. So we have 2 points at two different values, A and B. For any 2 points, A and B, or A does not equal B, if f of A and f of B have different signs, then there is at least one point C such that f of C is equal to 0. Basically, it says this. If the y value at A and the y value at B have different signs, then there is at least 1 point between A and B where the graph crosses the x-axis. If the y value at A and the y value at B have different signs, then there's at least 1 point between A and B where the graph crosses the x-axis, which means f of C is equal to 0. That's what it says. At A, this is positive. At B, this is negative. Since that's positive, that's negative, there has to be at least 1 point C where it crosses the x-axis. That's where y equals 0. That's what it says. All right, let's look what this means with some examples. But this will help us when we start figuring out different values. F of x equals x cubed plus x squared minus 6x. At A equals 4 and B equals -2. Oh, -4, -2. All right, so first, at A equals -4. Find f of A. So we have -4 to the third -4 squared, -6 times -4. Negative cubed is negative. 4 cubed is 64. Negative squared is positive, so it doesn't change. 4 squared is 16. Negative times negative is positive. 6 times 4 is 24. 16 plus 24 is 40. 64 is bigger, so it's negative. 64 minus 40 is 24. So at -4, the answer is -24. At b equals -2. Find f of b. F of -2, so it's -2 cubed, -2 squared, minus 6 times -2. Negative cubed is negative. 2 cubed is 8. Negative squared, positive, so it's positive. 2 squared is 4. Negative times negative is positive. 6 times 2 is 12. 4 plus 12 is 16. 16 minus 8 is 8. So what this thing tells us is this. 1, 2, 3, 4. At -4, we got -24. At -2, we get 8. So if we connect these two points, since they're opposite signs, this is negative, this is positive, there has to be at least one point C that crosses the x-axis. So there's at least one point C such that the y value is 0. That's what that tells us. Right. .3. Polynomial division. So we're getting, remember, this chapter, we're trying to be able to take any large polynomial and to be able to factor it, to find its smallest pieces. In this section, we're going to talk about two major pieces of information. The remainder theorem and the factor theorem. So with polynomial division, we have two types. Two types. One is called long division, and the other is called synthetic division. Synthetic. All right, so let's review division. 27 divided by 3. We could rewrite this like that. So the divisor goes on the outside, and the dividend goes on the inside. we ask ourselves, how many times is 3 going to 27? 9. So 9, then we take 9 times 3 and put the answer there. 9 times 3 is 27. We change the sign and then we add. 27 minus 27 is 0. This is called the 9 is called the quotient, and the 0 or whatever number down here is called the remainder. The 3 is called the divisor, and the 27 is called the dividend. So since the remainder equals 0, we know that 3 and 9 are factors of 27. So we have 27 over 3 equals 9. And we can check that. Multiply both sides by the divisor. 27 equals 9 times 3. All right, so that is the way we used to do it, just in numbers. Now we're going to do it with equations. With polynomial equations. X squared plus 6x plus 8 over x plus 2. What we're looking for here is now we're going to see if x plus 2 is a factor of that. How do we do this? So let's see. We have our divisor. Well, I'll put this in here. X plus 2. And inside there is a dividend. X squared plus 6x plus 8. The goal here in long division, this is called long division, is we only look at the leading terms. What times x gives me x squared? X. So once we have here, we multiply that to both of those. So x times x is x squared. Positive, positive is positive. X times 2 is 2x. Then we change the signs and add. So the first term has to disappear. If it doesn't, you did something wrong. 6 minus 2 is 4. And bring everything else down. Repeat the process. What times x gives you 4x? A positive 4. Positive 4 times x is positive 4x. Positive, positive is a positive. 4 times 2 is 8. Change the signs and add. 4 minus 4 cancels, 8 minus 8. So the remainder is 0. So since the remainder is 0, we know that this is a factor of x squared plus 6x plus 8. We also know that x plus 2 is a factor of x squared plus 6x plus 8. We have a fraction equals, let's check it. Check your answer. So multiply both sides by x plus 2. X squared plus 6x plus 8 equals x plus 4, x plus 2. So these are the factors of that. If we multiply these together, x times x, x squared, plus 2x, plus 4x, plus 8, 2 plus 4 is 6x. You see they're equal. So that means these are the factors. And there's only 2 of them because that's the degree. So that's what we're trying to do here. This will help us now figure out all the pieces of the puzzle. Here's another one. 4x cubed minus 3x squared plus x plus 7 divided by x minus 2. X minus 2, 4x3, 3x squared plus x plus 7. Very important. Since I start with x cubed, I have to have x squared, x and constant. Same here. If I have a x to the first, then I have to have a constant. If I'm missing any pieces, then I have to put a 0 in that place just to hold that location. Let's take this. Leading terms. What times x? Well, what times 1 gives you 4? 4. What times x give you x to the first, give you x to the third? How many x's are we missing? 2. 4 times 1 is 4. x2, x1 equals x3. Positive, negative is a negative. 4 times 2 is 8. x2. Change the signs and add. The first term has to disappear. 8 is bigger, so it's positive. 8 minus 3 is 5, x squared. Bring down everything else. Repeat the process. What times 1 gives you positive 5? Positive 5. X to the first times what gives you x to the second? How many x's am I missing? Just 1. Because 1 plus 1 equals 2. Positive, positive is a positive. 5 times 1 is 5. X times x is x squared. Positive, negative is a negative. 5 times 2 is 10, x. Change the signs and add. 5's cancel. 10 plus 1 is 11x plus 7. Repeat the process. Positive times positive is a positive. What times 1 gives you 11? 11. And there's the x already. So positive, positive is positive. 11 times 1 is 11x. Positive times negative is a negative. 11 times 2 is 22. Change the signs and add. All right, so what that tells me, this, since that's not 0, x minus 2 is not a factor of 4x cubed 3x squared Now let's look at this number here. Remember this number there. There's another way we could do it. So here's our original equation we had up on top. Because remember, we're looking for remainders of 0. If the denominator is not going to give us a 0, then it's not a factor. We don't have to worry about it. Here's another way. Solve the denominator. We have x minus 2 equals 0, x equals 2. Plug that value into the numerator. So we know that x equals 2. Put it in place of the numerator. Work it out. So we have 4 times 2 cubed, 3 times 2 squared, plus 2 plus 7. 2 cubed is 8. 2 squared is 4. 4 times 8 is 32. 3 times 4 is 12. 32 minus 12 is 20. 20 plus 2 plus 7 is 29. Same value as the remainder above. So that's one way another way you could do it. Take the denominator, solve it, plug it in the top. If it becomes a 0, then you know you have a factor. You can go ahead and go through the long division to see what the other factors are. If it's not a 0, don't mess with it because you don't need it. It's not going to be any purpose to you. These equations can be given to you in different ways. For example, you can get it given to you like this. Not 3, make it 2. That means the same thing as this, which means the same thing as this. all three of those mean the same thing. Let's go ahead and figure this out. So let's look at it both ways. Let's do long division here, and then I take the denominator, set it equal to 0, and plug that into the numerator. So it's 2 cubed is 8. 2 squared is 4. 3 times 4 is 12. 8 minus 12, 12 is bigger. 12 minus 8 is 4. Negative 4 plus 2, 4 is bigger. 4 minus 2 is 2. So I'm predicting that my remainder will be negative 5, which tells me that x minus 2 is not a factor of that. X to the first, how many x's are we missing? 2. X squared times x is x cubed. Positive negative is negative. 2 times x squared is 2x squared. Change signs and add. Negative 3 minus, so 3 is bigger, so it's negative. 3 minus 2 is 1. Bring down everything else. What times, no, positive times negative is negative. What times x gives me x squared? I'm missing x. You notice also in these answers, it always goes down 1x. So negative times positive is negative. X times x is x squared. Negative times negative is positive. X times 2 is 2x. Change the signs and add. Negative 2 plus 1 is negative 1. Bring down everything else. Positive times negative is negative. X times what is x? 1. So negative times positive is negative. 1 times x is x. Negative times negative is positive. 1 times 2 is 2. Change the signs and add. And there I have it. Let's do another one. 2x to the 5th minus 3x to the 4th plus x third minus 2x plus x minus 8 divided by x minus 2. 2x to the 5th, 3x to the 4th, x third squared x positive times positive is positive. 1 times what is 2? 2. I have 1x there. I'm missing 4 more x's. So 2 times 1 is 2. X to the 4th times x is x to the 5th. Positive times negative is negative. 2 times 2 is 4. X to the 4th. Change the signs and add. 4 minus 3 is 1. Bring down everything else. Positive times positive is positive. I have 1x, I need 4, so I'm missing 3. Positive, positive is positive. X3, x1 is x to the 4. Positive, negative is a negative. 2 times x cubed is 2x cubed. Change the signs and add. 2 plus 1 is 3, x cubed. Bring everything else down. Positive, positive is a positive. 1 times what is 3? 3. I have 1x, I need 3, so I'm missing 2 more x's. Again, see the exponents, 4, 3, 2, 1, 0. Positive, positive, positive. 3 times 1 is 3. X squared times x is x cubed. Positive, negative is negative. 3 times 2 is 6, x squared. Change the signs and add. Positive 6 minus 2 is 4x squared plus x minus 8. Positive times positive is a positive. 1 times what is 4? I need 2, so I'm missing 1x. I have 1x there. I need to have 2 of them, so I'm missing once again. 4, 3, 2, 1. 4x times x is 4x squared. Positive, negative is a negative. 4 times 2 is 8x. Change the signs and add. 8 plus 1 is 9x minus 8. Positive times positive is positive. 1 times what is 9? I'm missing 9. There's already an x. So 9 times 1 is 9, so it's 9x. Positive, negative is a negative. 9 times 2 is 18. Change the signs. So it's positive 10. So x minus 2 is not a factor. And you could have done the same thing. X minus 2 equals 0, x equals, take x equals 2, plug it inside here, and you'll end up with 10. All right. Now, there's a faster way, a shortcut. This is called synthetic division. Synthetic division only works if the denominator is of the form x plus or minus a number. So there's no coefficient, no exponent at the x, and just some number. Let's see how it works with this example. Here's an example. First step. Solve the denominator. So x plus 2 equals 0, x equals negative 2. We only use the coefficients. So this negative 2 goes there. That upside down division means synthetic division. Inside here, only the coefficients of the numerator. So here's the x squared column, here's the x, and here's the c. The coefficient of x squared is 1. Coefficient of x is 6 and 8. Begin by bringing down the first term. Now, multiply this times that and put it there. So -2 times 1 is -2. Add, going straight down. 6 minus 2 is 4. Repeat the process. This times this goes there. So -2 times 4 is -8. Add straight down. This is your remainder. If 0, then your factor is that number. This is the constant, and this is the x column. So by using this synthetic division, we know the answer is x plus 4. So x squared plus 6x plus 8 is x plus 4 times x plus 2. Let's take another example. X cubed minus 3x squared plus x minus 3, x divided by x minus 2. Again, if it can be given to you in a couple of ways. If it was given to you, both of these ways mean the same thing. This is your denominator, this is your denominator. It satisfies the condition, x plus or minus a number. So first step, solve the denominator. Okay, so we have, here's my x cubed column, x squared, x, and constant. So I'll just start with the highest exponent and just go down from there. Now, I look at my equation. What are the coefficients? 1, -3, 1, -3. Begin by bringing down the first term. 2 times 1 equals 2. -3 plus 2 is -1. 2 times -1 equals -2. Add straight down. -2 minus 1 is -1. 2 times -1 is -2. Add straight down gives me -5. That's your remainder. So it's not a factor. You see, synthetic division takes a lot less space and it's a lot faster. All right, here's another one. 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8 divided by x minus 2. Take the denominator, set it equal to 0, and solve. Since the highest exponent is x to the 5th, I make my columns. So the coefficient of x to the 5th, 2. X to the 4th, -3, 1, -2, 1, -8. Because if I'm missing any of this, I put a 0 in its place. Bring the first term down. 2 times 2 equals 4. 4 minus 3 is 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. 6 minus 2 is 4. 2 times 4 is 8. 8 plus 1 is 9. 2 times 9 is 18. 18 minus 8 is 10. There's your remainder. Let's look at another one. X plus 1. Because look at this. This equation, if we did long division, it would have taken up half the page. But synthetic division is pretty short and sweet. But it only works if it's in this form. X plus minus number, check. Take the bottom, set it equal to 0. -1. The highest is x to the cube, so it's x cubed, x squared, x, and constant. Coefficients. Coefficient of x cubed is 1, 2, -5. The constant is -6. Bring down the first term. -1 times 1 is -1. 2 minus 1 is 1. -1 times 1 is -1. -5 plus -1 is -6. -1 times -6 is 6. The remainder is 0. So we know that one of our factors to this equation is x plus 1. Another thing it tells us, since the remainder is 0, this is all we have to look at now. It starts with a constant term. This is the x, so it's 1x. It's positive. And that's constant x. This must be x squared. So all we have to look at is this equation for the other factors. So that becomes this, becomes this, becomes this. X and x, second sign, so it's opposite signs. The bigger number gets positive. What times what is 6? When you subtract them, you get 1. 3 and 2. So those are the factors. So what does that tell us? It tells us that the numerator is made up of these factors: x plus 1, x plus 3, x minus 2. We know the x-intercepts are at -1, -3, and 2, and so we know the y-intercept is at -6. There's a lot more stuff we could tell about it. All right, so that is how you divide polynomials. Again, we need these things so we can solve for our equations. theorems about the zeros of polynomials. Zeros is the same thing as solutions, as same thing as x-intercepts, as factors. So all these things mean the same thing, are synonymous, so it's pretty similar. So let's look at this first example. 3x cubed minus 14x squared plus 14x minus 4. Find the factors. The method we're going to use here is called the rational zero theorem. What it says is this: any polynomial, or every polynomial, is made up of these numbers: q, x to the n, p. You have a leading coefficient and you have a constant term. It's rational zeros because what we do now is we take the constant term divided by the leading term. And we're going to find all possibilities of all combinations that make up those two numbers. So in our example, q is 3 and p is 4. So it's 4 over 3. Now, what we have to do here is look at all the possible factors of what makes up 3. 1 times 3. 1 times 4 and 2 times 2. So these are the possible factors. So it's possibly plus or minus 1, plus or minus 2, plus or minus 4. Plus or minus 1, plus or minus 3. So we just factored out the q and the p terms. Remember, what this is doing is when we begin, we have an infinite number of numbers we can choose from: fractions, decimals, integers. What this is going to do is going to narrow down our possibilities to just these, because we have 3 on top, 2 on the bottom. So 3 times 2, 6 times plus or minus. We're narrowing down from infinite down to 12 possibilities. What these are looking at are plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1. So I'm looking at all these over each of these denominators. Then plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3. So 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, 1/3, 2/3, plus or minus 4/3. 1, 2, 3, 4, 5, 6 times 2. We now narrowed it down. It's got to be one of these. There's 3 answers. They've got to come from this, or we'll be able to find it with these 12 possibilities. So we went from infinity possibilities down to 12. All we have to do is try these 12 and I'll find the answers, the factors of that equation. So we use both positive and negative 1. So we use positive 1 and we use negative 1. Remember, we're looking for the equation 3x cubed minus 14x plus 14. So what we have here is x cubed, x squared, x and constant. So 3, negative 14, 14, negative 4. So let's begin. We're looking for a remainder of 0. 1 times 3 is 3. Negative 14 plus 3 is negative 11. 1 times negative 11 is negative 11. 14 minus 11 is 3. 1 times 3 is 3. 3 minus 4 is negative 1. So positive 1 doesn't work. Negative 1 times 3 is negative 3. Negative 3 minus 14 is negative 17. Negative is a positive. 1 times 17 is 17. 17 plus 14 is 31. Negative makes it negative 31. So that's not going to work. So let's try 2 and negative 2. 3, negative 14, 14. And I don't mind if you use calculators here because it'll just speed up the process. Bring down the first one. 2 times 3 is 6. Negative 14 plus 6 is negative 8. 2 times negative 8 is negative 16. Makes it negative 2. 2 times negative 2 is negative 4. Nope, that's not 0. 2 doesn't work. Negative 2 times 3 is negative 6. Negative 6, negative 14 is negative 20. Negative is a positive. 2 times 20 is 40. It's going the wrong direction. That's not going to work. Okay, let's keep on looking. It's got to be one of those possibilities. So the next numbers we have is 4 and negative 4, or 4 and negative 4. Try those. Three, negative 14, 14, negative 4. 3, negative 14, 14, negative 4. 4 times 3 is 12. 12 minus 14 is negative 2. 4 times negative 2 is negative 8. 6, 24 makes it 20. No. 4 times negative 3 is negative 12. Negative 26. Negative is positive. 4 times 26 is 118. Now this is getting much bigger, so that's not going to work. So the next we have are 1/3 and negative 1/3. So you have 3, negative 14, 14, negative 4. Bring on the first one. 1/3 times 3 is 1. 1 minus 14 is negative 13. Negative 13 times 1 is negative 13 over 3. That means I gotta make this is 14 over 1. Gotta make it over denominator of 3. So it's 42 over 3 minus 13 makes it 29 over 3. 1/3 times 29 over 3rd. 1 times 29 is 29. 3 times 3 is 9. So I get a common denominator of 9 up on top. So it's negative 36 over 9. Negative 36 plus 29 is negative 7 over 9. No. Negative 1 over 3 times 3 is negative 1. Because the 3's cancel. Negative 14 minus 1 is negative 15. Negative 15 divided by 3 is 5. Negative negative is positive. 14 plus 15 is 19. It's negative 19 over 3. And that's not going to work because that's 12 over 3. Negative 7. So that's not going to work. All right. We're running out of possibilities, but I have faith. Three, negative 14, 14, negative 4. Two-thirds times 3. The 3's cancel, leaving with 2. Negative 14 plus 2 is negative 12. 12 divided by 3 is 4. So negative 4 times 2 is negative 8. Makes it 6. 6 divided by 3 is 2. 2 times 2 is 4. 0. So there's our first answer. X equals 2/3 is our first factor. But now all we have to do is look at this one. It's 3x squared minus 12x plus 6. We can factor out a 3. So there's another factor part. Now we're going to solve this. We can't factor this, but 2 times 2 is what when you add them before. So we got to use the Pythagorean theorem. In our case, A is 1, B is negative 4, C is 2. Negative of a negative 4, negative 4 squared. Negative 4 is a positive 4. Negative 4 squared is 16. 4 times 2 is 8. 4 plus or minus 16 minus 8 is 8. Eight is made up of 2 times 2 times 2. So that means I can factor out a 2 out of there. On the top, they both have a 2, so I can factor out a 2 out of the top. Those cancel. So my last two answers are those? And then the 3 coefficient. So how do you solve this one? Multiply both sides by 3 and subtract. So it's 3x minus 2 equals 0. So there's my first factor. And the 3 in front. Move everything over. X minus 2 minus radical 2. And then x minus 2 plus radical 2. These are the factors of my answer, of my equation. Yes, that was a lot of work, but if you think about it, it was less work than if we had to do it by trial and error. All right, let's look at, hopefully I can pick one that's, find one that's easier. X cubed plus 2x squared minus 5x minus 6. Q is 1, P is 6. So that's 6 can be made up of 1 times 6 and 2 times 3. So the possible rational zeros are 1 over 1, 2 over 1, 3 over 1, 6 over 1. 1, 2, 3, 6. So these are the only ones I gotta try. I'm gonna have 3 answers. So let's try 1 and negative 1. So it's x cubed, x squared, x and constant. X cubed, x squared, x and constant. Coefficients 1, 2, negative 5, negative 6. 1, 2, negative 5, negative 6. Another 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 3 minus 5 is negative 2. 1 times negative 2. So that's not going to work. Negative 1 times 1 is negative 1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. Negative 5, negative 6 is negative 5, negative 1 is negative 6. Negative, negative, positive. So x equals negative 1 is one of my solutions. But all I have to do now is look at those. X squared plus x minus 6. X and x, opposite signs. What times what is 3 when you subtract them, you get 1, and the bigger number is positive, 3 and 2. So x cubed 2x squared minus 5x minus 6 factors out. This one is x plus 1 equals 0. X plus 1, x plus 3, x minus 2. So I took this equation, set it equal to 0, I get x plus 1. That's the first one. Then these two. So there's the factors. There are the factors. X-intercepts are at -1, -3, and 2. Y-intercept is at -6. Let's do another example. X cubed minus 2x squared minus 9x plus 18. P is made up of 18. Q is 1. So what makes up 18? It's 1 times 18, 2 times 9, 3 times 6. So 1, 2, 3, 6, 9, 18. Positive, -1, 2, 3, 6, 9, 18. So these are our answers I can choose from. All right, so let's begin with 1, -1. X cubed, x squared, x and a constant. X cubed, x squared, x and a constant. The coefficients. 1, -2, -9, 18. 1, -2, -9, 18. Bring down the first. 1 times 1 is 1. 1 minus 2 is -1. 1 times -1 is -1. -1 plus -9 is -10. -10. So it's 8. Nope. -1 times 1 is -1. -1 plus 2 is -3. 1, -1, -3 is 3. -6 makes it 6. Makes it 24. No. So not 1. Let's try 2. And -2. So we have our 1, -2, -9, 18. 1, -2, -9, 18. 2 times 1 is 2, 0. 0 times 2 is 0. -9 plus 0 is -9. 2 times -9 is -18. 0. So that's our x equals 2 is our answer. All we have to do now is look at this one. It's 1x squared plus 0x minus 9, which is x squared minus 9. Factor is not equal to 0. So this is x squared minus 3 squared. It's the difference of 2 squares. So it's x plus 3, x minus 3. And that one. So these are my factors of x cubed minus 2x squared Now, there is a way we could narrow this further because, again, we start off with infinite possibilities. We use the rational zero theorem to narrow it down even further. So from infinity, we have 1, 2, 3, 4, 5, 6. 6 times 2. From infinity, we went down to 12. There's a way now we can go even further. We can tell how many numbers or answers are going to be positive, how many answers are going to be negative. We do that by using what's called Descartes' rule of signs. Remember, this is the same guy, René Descartes, who invented the Cartesian coordinate system, the X and Y graph. This system tells us the number of positive, negative, imaginary, or radical answers. Okay, here's a side note. And radical answers always come in conjugate pairs because I times negative I is negative I squared. I squared is negative 1. It's 1. So in order to get rid of the imaginary numbers, we have to multiply by its conjugates. Same thing with the radicals. Radical x times radical x is radical x squared equals x. All right, so also if we have our answer is 2 plus I, then we know we also have to answer 2 minus I. Or if our answer is radical 5, then we know our answer has to be negative radical 5. So they always have to come in conjugate pairs. Here's our polynomial. All right, remember we did this before. Our answers we got our factors were x plus 3, x minus 2, x plus 1. So using Descartes' rule of signs, number of positive answers. Simply count the number of sign changes in the original function p of x. So 2x squared minus 5x minus 6. So number of sign changes. From positive to positive, nope, that's not a change. Positive to negative, that's 1. Negative, negative. So we'll have one positive answer. To find the number of negative solutions, count the number of sign changes in p of negative x. So now we anywhere we see an X, we put a negative X. And here's the thing. If you have an odd exponent and of a negative number, the answer will be negative. If you have an even, if the negative isn't even, it just cancels out, so nothing changes. Negative is a positive. So the number of sign changes here, negative to positive is 1, positive to positive, no, positive to negative is 1. So number of negatives will have 2 or 0. The reason being because if one of the answers are imaginary or radical, then it has to be 2 of them. So if our answer is not straight up negative, then it's going to be imaginary or radical. But we already know, since our factors are x plus 3, x minus 2, x plus 1, and we set them equal to 0, we get x equals negative 3, x equals positive 2, x equals negative 1. We have 2 negatives and 1 positive. So that's how Rene Descartes' rule of sign works. All right, let's look at another one. One more, and then we'll call it a day. X cubed minus 2x squared minus 9x plus 18. So let's see how many positive answers we'll get. Positive to negative is 1. Negative to negative, nope. Negative to positive is 1. So for positives, we'll have 2 or 0. Let's see how many negatives we'll get. Odd power, so it used to be positive, now it's going to be negative. Since this is even, nothing changes here. It's an odd power, it's 1, so that's going to change. Negative, negative, nope. Negative, positive. So number of negatives, 1. And when you work this one out, you'll get these answers. So x will be positive 2, x will be positive 3, and x will be negative 3. Sorry. You have these factors. We have 1 negative and 2 positives. All right, so that is the process of solving polynomials. All right, good luck, everybody.